Okay, today we're talking about polar coordinates. We're going to graph points with polar coordinates and graph simple polar equations. So, before we start, I want to refresh your memory on what you already know. Before, everything you've done up to this point, you've named your points in relation to the origin and the x and y axes. Now, our points are going to be named in relation to the pole and what is called the polar axis. Okay, so again, going back to what you've done before, you had an x and a y, you had the origin, and x described your left and right motion, y described your up and down motion, so your horizontal and vertical, all starting from the origin. Now we're going to have points that look like r and theta. Now, this polar axis is also known as the positive x-axis. And so when you graph, okay, and these points are theta, r is going to be the distance from the pole and theta is going to be the angle made with the polar axis. And as we just said above, that's the same thing as the positive x-axis. So I have a sketch here. All right, this right here is going to be your polar axis. Okay, this right here is your pole. So that's your starting point. Okay, now to graph any point, you got to think about it's all with a distance and an angle made, which is similar to our vectors. Okay, so if I have one here, it matters which way you're facing. So hopefully y'all can tell from here that my arrow is pointing up. Okay, I have to make it in the direction. I always want to start in the direction with my polar axis. So when you think about graphing a point, basically we start with our angle and we have to be facing the polar axis. And whatever my theta is, okay, if it's, here's 0, okay, that's what we have from our unit circle. If theta was 180 degrees, then I would turn and face this direction. If theta was 90 degrees, I would be facing this direction. But whatever your theta is, you're going to go starting at the positive x-axis and go in a clockwise motion. So then you have somewhat a vector array coming out from that point. And then your r tells you how far out to go. So you're thinking about units on this ray, this vector, and however far you go to plot that point, if this is the spot right here, then the distance from here to here is going to be my r. This right here is your angle theta, okay? And we're going to talk about it, but remember the negative sign here, just like we have with our distance, okay, um, tells us the direction, okay? So again, these are our rectangular coordinates, and these are polar coordinates. And as I said, um, when you want to graph these, you always start with the angle, and then you graph the r. So let's go, we're going to go sketch some, and we're going to plot some on polar paper. Okay, so to start off with, sketching, all right, graph each point. This is the point, -1 comma pi over 2. So that's my r, and that's my theta. So if you were to draw pi over 2, we always start with the, that doesn't look too good. Oh, you know what I can do? Because I have these nice little tools. Let's go here. I can start with a ray. So my ray is going to look like this. All right. Oh, yes. Okay. I always forget that. There's my positive x-axis. Where's pi over 2? Straight up. All right. So this describes, and this is how you have to do it, okay, when you're sketching it. This describes theta. Okay, actually we won't write theta because we have the specific angle. This is going to be pi over 2. And then if I was going in the positive direction, I would walk forward because it's the negative direction, and generally we dot it as we go down. And I'm going to go how many units down? 1 unit. So that negative sign tells me not to go forward. Remember, we're facing this way. So I turn and I'm facing that way. That's what that arrow says. But I got to walk backwards. So I walk backwards 1 unit. And that's my point right there. Okay, let's go do B, which is 2.5, 240. Okay, again, this is R and this is theta. So I'm going to go graph 240 and let's go get. So again, starting with your pot. Oh, that's a little too fat. Let's change that one. Do my, let's go back to here. All right, so I have my positive x-axis. Where is 240? So hopefully y'all remember that 240 is, remember if it was 280, I mean, excuse me, if it was 180, it would be down here, and this is 270. So 240 is going to be that angle that is 60 degrees past 180. So that's about right there. Okay, so we draw that, and we're going to label it as we're sketching it here. So this angle is 240 degrees. We're showing that direction, and we go out. So if I put tick marks, 1, 2, 3, but I'm going to go out 2.5 units. So there is my point. Let's label that point E. And we'll go back and label this one point D, so we know exactly where it is. Okay? And again, so let's go do F this time. So we had a negative R, positive theta. We had a positive and a positive. And now we have a positive R and a negative theta. So hopefully you remember how to draw that. We have, let's go with uh, our positive, always starting with our positive x-axis. And negative pi over 5 pi over 6 is going to be just before negative pi, so it's going to be just a little bit before, which is going to be about right there. Okay, and again, we're sketching. So we have this being that angle of negative 5 pi over 6. I'm going in the positive direction, so I'm going to go out 1, 2, 3, 4, and plot my point. And that is point F. So that's how you're sketching it. Now let's go do some on Polypipe and find out it's a little bit easier because they've already done all the angles for you. Okay, so we have, again, R, theta, always going to start with your theta. Find 7 pi over 6 on here. Oh, excuse me, it's negative 7 pi over 6. Okay, negative 7 pi over 6. If I start here at 0, uh, that's pi. So this is 7 pi over 6, but I have to go in a negative direction. So I go negative 7 pi over 6 because I gave you some nice paper that allows you to do that. And then I'm going to go out 1.5 rings. So I just have to go halfway. And you don't have to label it because it's already labeled on this. So this would be point R. Okay. Pause if you want to. Try to do this one by yourself and then start back up and we'll see if we match. Okay. This is R. This is theta. Negative 135 is going to be this line. That's my angle that's negative 135. And remember, if I want to go negative, I don't go that way, but I go backwards. 1, 2. So my R is going to be, excuse me, my S is going to be right there. Okay? So, plotting the next point, plot 4 3/4. So I go and plot this point. I'm going to go to 3/4. Again, always starting positive x-axis. 3/4 pi, 3 pi over 4. And I'm going to go out 4. 1, 2, 3, 4. So I got this point right here. Okay? if I kept r as positive, but I wanted a negative angle, remember that this is, as we just showed, that's 3/4 pi. So you should all remember from our trig chapter um, how to get to what would be a negative angle that ends at that same place. So if I start at 0 and go this way, it's not 3 pi over 4, but hopefully you can tell me that that is negative 5 pi over 4. Okay, my r stays the same at 4. Okay, or if I wanted you to give me an angle, keeping r positive, and give me an angle between 2 pi and 4 pi. So that means that I would start at 0, go all the way around, and then stop. So I'm at 3 pi over 4 plus 2 pi, because I went all the way around again. 2 pi over 2 pi is the same as 8 pi over 4, so that gives me 11 pi over 4. Again, my r stayed positive. And this one asks me, give me one that r is negative but stay between 0 and 2 pi. So if I went 100 or 3 pi over 4 and I wanted to go here, that would be positive, but I need my r, I need to go backwards. So if I go backwards, what you want to think about is what's on that same straight line with it. So basically you're going pi or 180 units in the opposite direction. So instead of going 3 pi over 4, I'm going to go to negative pi over 4. And negative pi over 4, if I went that far, then I would go backwards 4 units. So that would give me a negative r value. Okay? Now, the most important thing to get from this is how many different ways can we name polar coordinates? I said many, but I'm hoping that you can pick up on the fact that it's really infinite because I could name when you have an angle, we've talked about the fact that coterminal angles, there's an infinite number because you can go around the circle as many times as you want, and being a positive or a negative. So let's go do some, name some more. Okay, find 3 additional pairs of polar coordinates that name the given point if we got theta between negative 360 and 360 or between negative 2 pi and pi. So we start off with 240, so we're using 360 and 60. Whatever it's given to you, you want to keep that same thing. So first off, to get the same one with a negative, all you need to do is subtract 360. So that's going to be 5 comma, what's 240 minus 360 is negative 120. Okay, so that's your first one. Now, to get the second one, if you think about the 240 and take 180 away from 240, take 180 away, then we're at 60, okay? But when you take 180 away, then that makes your R negative. So now I'm at negative 5 comma 60. And then from this one, let's go for, I'm going to draw it down from here because I'm taking that one and giving a negative angle with it. And that gives me negative 5, subtract 360, and we get negative 300. So we have now named 3 points, 3 different ways of naming the same point. Okay, a similar fashion in radians. Okay, instead of doing 360, I'm going to do 2 pi. So I'm going to subtract 2 pi from it to get my first one. And this is where y'all got to remember your fractions. 2 pi is the same thing as 12 pi over 6. Okay, so we're subtracting that. So I start off with 2 pi over 6 minus 12 pi over 6 is negative 11 pi over 6. Okay, and then I start from that beginning one and I'm going to subtract pi. Okay, when I subtract pi, that's 6 pi over 6. Pi over 6 minus 6 pi over 6 is, oh, I can add, you can add it or subtract it, either one. So I subtracted over here because it was big. So we can go with negative 5 pi over 6. We'll make the next one positive. So that's negative pi over 6. And because I'm on the 180 or the 6 pi over 6, then that changes my r to a negative. It's only when you're changing the original one by 2 pi or 360 that your r stays the same. Once you get into the 180 or the pi, then your r becomes negative. So if I take the pi value now, and as I said, or you can think about adding pi, I can add pi to this one, to this original one, and that gives me negative 2, 7 pi over 6. So again, I have my 3. So when you're adding from the original one, if you're adding 180 or pi to it, then your r should be the opposite of what you started. If you're adding 360 or 2 pi, then your r will be the same. Okay? All right. The next thing we got to talk about are some simple equations that we have in polar form. Okay? In polar form, graph each polar equation. R equals theta. I told you to do it twice, but you only have to do it once. Okay? If r is 3, think about where r is 3. So if I start here at 0 degrees, r is 3. 1, 2, 3. Okay? What if I went 90 degrees and r is 3? I would end up here. If I went 45 degrees and r is 3. What if I went negative 240 or positive 240? That r is 3. 1, 2, 3. So hopefully you can see by now that if you continue with that, then you're going to end up, actually I'm going to draw it as a highlighted figure. It will be, if they'll let me, it may not let me because it may straighten up on it. A nice circle, and that's not a nice circle, but y'all can draw nice circles. Because this is the points on the circle where r is 3 every single time. So what's it going to be like if theta is 2 pi over 3? If theta is 2 pi over 3, where is 2 pi over 3? Pi over 3, this is 2 pi over 3. So if I go to 2 pi over 3, r can be anything. So r can be anything because theta is 2 pi over 3. Back over here, theta can be anything you want it to be. So if you need to think about points to plot. So I go to 2 pi over 3 and I make r be positive or negative, or it could be a fraction. So hopefully you see when you plot all those points, what are we going to have but a line that goes through theta 2 pi over 3. Okay, last thing we got to talk about is the polar distance formula. Okay, we have 2 points here. Let's go with point 1 is r sub 1 theta sub 1. Point 2 is r sub 2 theta sub 2. These are my points on polar paper. Okay? Now watch when I write this because it is very similar to what you've seen before. I take the first one, square it, the second r, and square it. Then I subtract 2 times the product times the cosine. So I know y'all were just dying to tell me that that looks a lot like the law of cosines that we just dealt with. The only difference is we got to take the square root of it, just like any distance formula. But our theta, we actually subtract them. Does it matter which one you start with? Think about that. And I'll tell you the answer is no, it does not matter because cosine is an even function. So whether this angle is positive or negative, you'll get the same value. Okay? All right, let's look at this last problem. A naval radar is tracking 2 aircraft carriers. The coordinates of the 2 carriers are 8, 150, and 365 with R measured in miles. Sketch a graph of the situation. Okay, so if I were to go plot that, let's go plot some nice little. All right, I start at 0, and if I go to 150, that's going to be over here. And we'll make it longer because I'm going to go out to 8. And then if I go plot 65, 65 is going to be somewhere around here, something like that. Okay, so I have My 8 150 puts a point 8 units right here. Okay, as if that was 7 6 5 4 3 2 1. Not drawn to scale. Sorry about that. And then this one would be 1 2 3. So there's my other point. So we are looking for the distance between these two. So it's this distance. Okay, and that's our sketch. Okay, and actually I should label it. This, of course, is 65, and this one is 150. Okay, so what is the distance between the two carriers? We're going to use our formula. It says r squared, which would be 8 squared, plus 3 squared, minus 2 times 8 times 3 times the cosine of, subtract the two angles, 150 minus 65. So put that in your calculator and you will get an answer of 8.29, and they told us it was miles. So that's our answer. And that sums up polar coordinates.